All right. So in today's class, we're going to look at second theorem questions, and we'll start off with looking at some of the basic principles that we must understand. Firstly, is this one saying the angle in a semicircle is 90 degrees. So the semicircle is just half of the circle. So if you have a chord going through the center to the other circumference, which cuts the circle into half, and then the angle which will be at the circumference way there like that is going to be 90 degrees. That's what it's saying. Then this one here is telling us that the angle at the circumference is half the angle at the center. So the center here, the angle that is at the center, in this case is 120. So 120 divided by 2 gives us what? 60. So the angle at the circumference there is going to be half the angle at the center. Then the other one is the angle in the angles in the same segment form a common chord and are equal. So angles what in the same segment like this here you see form this common chord where this when it starts from here, so this line starts from here to the circumference and ends there. And then you have starting from the same point to just another point at the circumference and ending there, the angles they are going to be what? Are going to be equal. The opposite angles in a cyclic quadrilateral always adds to 180. So the opposite sides, so in a quadrilateral, so meaning it has what? 4 sides like that. Then this angle, so this angle is 100, so opposite that angle is 80. So the sum of the two angles always adds up to what? 180. Same even this side, the sum of the two angles adds up to what? 180 degrees. And the whole thing here adds up to what? 360 degrees. Okay. The other one, we have the angle between a radius and a tangent is 90 degrees. So if you have a tangent is just a line that touches the circumference only at what? A single point. And so the angle which is formed between the tangent and the what? And the radius. So the radius, that's from the center to the what? The circumference, that angle is 90 degrees. Then we're saying alternate segment theorem, which is the angle between the chord and the tangent is equal to opposite angle inside the triangle. So this angle here, that is here, if you have a tangent like that, and then you have a line forming like that, and then you have this angle here is going to be equal to that angle there inside the alternating what side like this. And then this angle is going to be equal to that one there like that. So that's what this rule is telling us. And the tangents to a circle from the same point to be equal in what? In length. The tangents to a circle from the same point will be equal in length. So if I start from here, it's a tangent going to that side, touches one part at the circumference and the other one like that. So these lines are going to be what? Are going to be equal. And they're saying the radius through the midpoint. So the midpoint of a chord will bisect the chord at 90 degrees. So this is a chord here, and you have a radius passing through there, and that there will bisect it or cut it at 90 what? Degrees. Okay, so these are some of the basic rules that you must know when you are dealing with what? Second theorem. So now, if there's no question, we can begin now to answer this question. So answer 2 questions like that, step by step. If you have any question, feel free to ask. Just unmute your mic and speak. So in the following diagram, we have A, B. So A is here, B is there, C and D are points on the circumference of the circle. And then center O is there. Then BD is the diameter. And then AC, AD, and SC are equal. So you can see they've indicated like that they're equal. And the angle, so they've given us the angle BDC. So meaning the angle here is what? 22 degrees, which is that 22 there. So we see this is a cyclic quadrilateral. The A, B, C, D, because it has four sides like what? Like that, and they're touching the circumference. Okay, so the first one, they're telling us to find the angle BAC. BAC. So BAC. They're telling us to find this angle here, BAC. So how do we find that angle there? So from the theorem, or from that rule which we said that if we have angles on the same segment that form a chord are going to be what? To be equal. So meaning here when you're at B, so it's going from B to A, then to C like that. That's forming there. But again, you see it's starting from B, going to the what? To that point there, and then from there to what? To C here. So meaning that this angle here and that angle there are what? Are equal. So meaning that this angle here is what? 22 degrees. So meaning ABC is just what? 22 degrees by that rule. Okay, next you have CBD. CBD. So CBD. So that this angle here, CBD. So they're telling us to find this angle here. So how do we find that angle? So we say that, so remember the rule which we said that if we have a semicircle, since they said this is O is the center, and they told you that BD is the diameter. So you know that this here is cutting the circle into what? Into half, and you're making a semicircle. So the angle that is within the semicircle, meaning this angle here, is what? Is 90 what? 90 degrees according to that rule. So you have this here, it's going to be 90 degrees. And then you have 22 here. So now angles in the triangle add up to what? 180 degrees. So to find this angle here, we're just going to say you add the 90 degrees plus what? Plus, okay, so let's call this angle. Maybe let me call it, we call this angle, the angle here, we call it X, such that we say 90 degrees plus 22 degrees plus X is going to what? Is going to be equal to 180 degrees, since angles in a triangle add up to 180 degrees. So when we add now, we add 90 plus 22, we're going to have 112 degrees plus X is equal to 180 degrees. And this is going to be, so X, 122 goes the other side, it becomes the additive inverse of positive 122 degrees. This is going to be what? Negative. So you have 180 degrees minus 112. So this is going to be 180 minus 112. And then this here just gives me what? Gives me 68 degrees. So meaning that angle CBD is just 68 degrees. Okay, that's that angle. All right, let's find the last one. The last one is they're telling us to find ACO. A, where's A? A is there, A, then C, then O. Okay, let me wrap this here in green. So they're saying to find ACO. So they're telling us to find this angle there. Okay, so how do we find that angle there? So what we can do is we can find this angle here, this one here. Can find this angle here and find that angle there. So let's follow the steps of how we're going to do this one. So since this here is the center and going to there, to the circumference, and there from the center to the circumference, it means the distance from here to there and distance from the center to that point are the same. Since the radius, we know that the distance is a distance from the center to what? To any point on the what, and it's going to be of the same distance. So we know that angles that are like this, so they are meaning we're going to have something like this. This side and this side is equal, and this side is 22 degrees. So meaning that we know that even the angle here has to be what? 22 degrees. Since if they have equal sides, meaning the two angles are equal, and then this angle is the one which is what? Different. So you have that. So we add 22. Since angles in a triangle add up to 180, so we say 22 plus 22 plus this angle, let's say we call it y. So we call that angle y. Then we're going to have y plus 22 degrees plus 22 degrees should be equal to 180 degrees. And this is going to be y is equal plus 44 degrees is equal to 180 degrees. And you have y equal to 180 degrees minus 44. And this is going to be, so 180 minus 44, this is going to be 136 degrees. So you have 136 degrees. So 136 degrees is this angle here. And that's the angle at the what? At the center. So 136 degrees is that angle there, which is the angle at the center. Then this small angle here, we said is 22. So we have 136 degrees there at the center. So we can find this angle here. So that angle is half the angle at the center. So meaning we just say, to find this angle there, we just say 136 degrees divided by what? 2? Divided by 2, and we're going to have 68. So this angle here is what? 68 degrees. So how is that angle helping us? So that angle is helping us in that this side and this side, they've told us they're equal. So it means that the angle here from here to there is equal to the angle from there to there, like that. These will be equal angles. So we can find the whole angle here. So that will be, this, since this whole adds up to 180, so it means that I'll have 68 degrees. Then you have x, so this can be x, and that we name it x. That's that we have x plus x is equal to what? 180 degrees. And then you have 2x is equal to 180 degrees minus 68 degrees. So that is going to be 180 minus 68. That gives me 112. 112 here. 112 degrees over 2x. Divide by 2, x is going to be equal to, so divide by 2 there, and you just get 56. So this will be 56 degrees. So it means this whole angle here is 56, and this one also here in red is what? 56. So 56, we have 56 here degrees, and there we have what? 56. 56 what? Degrees. So now, okay, let's erase this. Now we get to how we get to the answer. So we keep that. And so what did we find? This whole angle from here to here is 56. But we want this small angle. What we want is this angle here. This small one here. This one is the angle that we want, since they're saying A, C, O. Okay, so that's the angle we want. But then this here, we have that this angle here, we have this small one is 22, and the whole thing is what? 58. So in short, we are saying 22 degrees plus, let's call this angle that we want Z. Z must be equal to what? The whole angle there is what? 56. Must be equal to 56. Such that you have Z is equal to 56 degrees minus what? 22 degrees. So 56 minus 22 degrees, that is going to be equal to 34 degrees. So therefore, the angle ACO is just 34 degrees. Okay, so that's how you find this here. Okay, I don't know if there's any question before we move on to the next one. All right, so the next one then is, we have the next one is in the diagram below, they're saying A, B, C, D, A, B, C, D, and E. A, B, C, D, and E. A, B, C, D, and E are points on the circumference of the circle with the center O. So the center is O, and we have the points, as they've said, A, B, C, what? DE. And then you have DE is equal to what? So DE here is equal to D what? DA, and they've indicated by these here. And then you have the angle ACD. ACB, angle ACB. Angle ACB, that is ACB ACB is 20, which is here. ACB is 20, and then the angle ADE or E. A or E. A or E is what? Is 80. Is 80, and it's indicated there, it's 80 degrees. Then they're telling us to find the angle ADE. So ADE, which is this angle here, ADE. Okay, so how do we find that angle there? So we know, since this angle here is 80 degrees, the one which is what? At the center. So at the center it's 80 degrees, and we know that the angle at the circumference is just uh, half the angle what? At the center. So we just say ADE is going to be half what? Half the angle which we're given, which is AOE, half that angle, and that is just 80 degrees divided by 2, which is going to give us 40 degrees. Okay, so we get that this here is just 40 degrees. The next we are asked for D. Okay, next we are finding DAE. 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 So this angle here, DAE, that angle there. Okay, so this is 40, and then they've told us that this part and this side are equal, meaning this angle which we are finding this side and this other angle here are going to be the same. So that means that to find that angle, we're going to say 40 degrees plus, so x plus x will be 2x, so we get 2x. And then this here should be equal to what? This should be equal to 180 degrees, since the angles in a triangle add up to 180 degrees. Then this is going to be 2x is equal to 180 degrees minus 40 degrees. And this here will give me 2x is equal to, that will be 140 degrees. Then divided by 2, I'll have 140 divided by 2, that gives me 70. So 70 degrees. So the angle DAE, the angle DAE is just 70 degrees. So this angle here is 70 degrees. Okay, let's now find the other one. So we make space here. Okay, so the next one is BAD. So B here, A, and then D. So we want to find this angle here, BAD, that angle there. So how are we going to define that angle there? So, okay. So we can find this angle here by saying, so we have, let me erase here a bit. Okay, so we can find this angle here, that part there in red, from here to there, since they're asking for BAD. So what we'll use is we'll first find this angle here, and then we'll use that there. So this angle here, let's find this angle. So how we find that angle there? So since we have A here, so at A, if we move from A to D, then to B, and then we move also from A to C and then back to D, you see that we form those those angles that are on the same segment. So you find that this here angle, the 20, and this one there are going to be equal. So it means that this side here is going to be what? Is going to be 20 degrees. So if that is 20 degrees, it means that this whole angle, the entire angle from this here to there, is just going to be an addition of the 20 and the 40. So you just say 40 degrees plus what? 20 degrees, like that. So, and then this here just gives us what? This just gives us 60 degrees. So we have 60 degrees there. But now we can form a what? A quadrilateral cyclic here, where we have, when we move from A to what? To E, to D, to B, like that. So those are 4 sides that are what? So 4 points like that, which form these sides that are what? That are in the circle. So you have 4 points going to the circumference like that. They form the quadrilateral. So the opposite side now, so if you have a quadrilateral, we said the opposite side or the opposite angles must be equal to what? Must be equal to 180 what? 180 degrees. So meaning this angle here, which is 60, when we add it to this angle, which is the angle when we move from here to there, like that, this angle here must be what? Must give us a 180 degrees. So if I subtract, I'm just going to have 180 degrees minus 60 degrees. This here gives me 120 what? 120 degrees. So from here, the big one in red is what? 120 degrees. But now, our concern is to find what? Is to find this angle here. This angle here, this one here. So this small one here is what we want to find, that angle there. So how do we then do that? So we know that this side, the whole angle has to add up to 120 degrees. But we have a 70 here, we know, and that we don't know. So if we call this x, and then we say x plus what? Plus 70 degrees must give us what? The 120. The 120 degrees here. And then you have x is going to be equal to 120. You take the 70 the other side, like that, they subtract. And this here is going to give us, you just have 120 minus the 70 gives you what? A 50 there. So you have 50 degrees. So meaning your answer here, the BAD is just 50 degrees. Okay, so that's how we solve that question. All right, I don't know if there's any question, but we are done. Okay, thank you. Since there's no question, we end here for today. We see you in the next class. Precious was calling.